12. Indirect derivation first form. System SL is now a complete set of rules for sentential logic. Every valid argument of sentential logic can be proved valid in System SL. System SL is also consistent, which is to say that no invalid argument can be proven in System SL. Demonstrating these two very important logical facts that System SL is both complete and consistent is well outside the scope of introductory logic. It rather falls under the scope of metalogic, which is studied in more advanced courses in logic. Even though System SL is complete as it stands, we will nonetheless enhance it further, thereby sacrificing elegance in favor of convenience. Consider the following argument form. A 1 PQ. Using truth tables, one can quickly demonstrate that a 1 is valid. What happens when we try to construct a derivation that proves it to be valid? Consider the following start. 1 PQPR 2 PQPR 3 P 4. An attempted derivation, using DD and CD, might go as follows. Consider line 3, which is a negation. We cannot show it by conditional derivation. It's not a conditional. That leaves direct derivation. Well, the premises are both conditionals, so the appropriate rule is arrow out. But arrow out requires a minor premise. In the case of 1 we need P or Q, in the case of 2, we need P or Q, none of these is available. We are stuck. We are trying to show P, which says in effect that P is false. Let's try a sneaky approach to the problem. Just for the hell of it, let us assume the opposite of what we are trying to show, and see what happens. So right below P, we write P as an assumption. That yields the following partial derivation. 1 PQPR 2 PQPR 3 P 4 P as 6 Q1, 4, 07 Q1, 5, 08 Q and Q5, 6, and we have gotten down to line 8 which is Q and Q. From our study of truth tables, we know that this formula is a self-contradiction. It is false no matter what. So we see that assuming P at line 4 leads to a very bizarre result, a self-contradiction at line 8. So, we have shown, in effect, that if P is true, then so is Q and Q, which means that we have shown P, Q and Q. To see this, let us rewrite the problem as follows. Notice especially the new show line 4. 1 PQPR 2 PQPR 3 P 4 PQ and Q CD 5 P is 6 Q and Q DD 7 Q1, 5, 08 Q2, 5, 09 Q and Q7, 8, and this is okay as far as it goes, but it is still not complete. Show line 3 has not been cancelled yet, which is marked in the annotation column by. Line 4 is permitted. By the show line rule we can try to show anything. Lines 5 and 6 then are written down in accordance with conditional derivation. The remaining lines are completely ordinary. So how do we complete the derivation? We are trying to show P. We have in fact shown P, Q and Q. In other words, we have shown that if P is true, then so is Q and Q. But the latter can't be true, so neither can the former by modus tollens. This reasoning can be made formal in the following part derivation. 1 PQPR 2 PQPR 3 PDD 4 PQ and Q CD 5 P is 6 Q and Q DD 7 Q1, 5, 08 Q2, 5, 09 Q and Q7, 8, and 10 Q and Q. 11 pages 4, 10. Oh, this is an okay derivation, except for line 10, which has no justification. At this stage in the elaboration of System SL, we could introduce a new system rule that allows one to write A and A at any point in a derivation. This rule would work perfectly well, but it is not nearly as tidy as what we do instead. We choose instead to abbreviate the above chain of reasoning considerably, by introducing a further show rule, called indirect derivation, whose intuitive formulation is given as follows. Indirect derivation first form intuitive formulation. In order to show a negation A, it is sufficient to show any contradiction, assuming the unnegated formula, A. We must still provide the official formulation of indirect derivation, which as usual is considerably more complex. See below. Recall that a contradiction is any formula whose truth table yields all F's in the output column. There are infinitely many contradictions in sentential logic. For this reason, at this point, it is convenient to introduce a new symbol into the vocabulary of sentential logic. In addition to the usual symbols, the letters, the connective symbols, and the parentheses, we introduce the symbol in accordance with the following syntactic and semantic rules. Syntactic rule is a formula. Semantic rule is false no matter what. Alternatively, is a zero-place logical connective, whose truth table always produces F. In other words, is a generic contradiction. It is equivalent to every contradiction. With our new generic contradiction, we can reformulate indirect derivation as follows. Indirect derivation first form second formulation. In order to show a negation A, it is sufficient to show assuming the unnegated formula, A. In addition to the syntactic and semantic rules governing, we also need inference rules. In particular, as with the other logical symbols, we need an elimination rule, and an introduction rule. These are given as follows. Contradiction in IAA. Contradiction out L. We will have little use for the elimination rule, O, it is included simply for symmetry. By contrast, the introduction rule, I, will be used extensively. We are now in a position to write down the official formulation of indirect derivation of the first form. We discuss the second form in the next section. System Rule 7. A show rule. Indirect derivation first form. If one has a show line of the form A, then if one has as a later available line, and there are no subsequent uncancelled show lines, then one is entitled to cancel A and box off all subsequent lines. The annotation is ID. System Rule 8. An assumption rule. If one has a show line of the form A, then one is entitled to write down the unnegated formula A on the very next line, as an assumption. The annotation is as. As with earlier rules, we offer a pictorial abbreviation of indirect derivation as follows. Indirect derivation first form ID as. With our new rules in hand, let us now go back and do our earlier derivation in accordance with the new rules. Example 1 1 PQPR 2 PQPR 3 PID 4 PS 5 DD 6 Q1 4 07 Q2 4 086 7 I. On line 3, we are trying to show P, which is a negation, so we do it by ID. This entails writing down P on the next line as an assumption, and writing down on the following line. On line 8, we obtained from lines 6 and 7, applying our new rule I. Let's do another simple example. Example 2 1 PQPR 2 QPPR 3 PID 4 PS 5 DD 6 Q1 4 07 pages 2 6 084 7 I. In the previous two examples, is obtained from an atomic formula and its negation. Sometimes, comes from more complex formulas, as in the following examples. Example 3 1 PQPR 2 PID 3 PS 4 DD 5 PQ3 I 6 1 5 I. Here, comes by I from PQ and PQ. Example 4 1 P and QPR 2 PQ CD 3 PS 4 QID 5 QS 6 DD 7 P and Q3 5 and I 8 1 7 I. Here, comes by I from P and Q and P and Q.